I'm Susan White, and I'm an associate professor in Michigan State University's Department of Media and Information. And in this lightning session, I'm going to talk about my efforts to teach Kenyan computer science students how to apply a human-centered design approach to their technology development efforts. So the United States and Kenya are global centers of innovation and entrepreneurship. Software developers in these countries are leaders in developing and commercializing the latest technological advances in mobile money and artificial intelligence. However, the skills needed to maintain this leadership are changing. Creativity, empathy, collaboration, and critical thinking are becoming as necessary as traditional technical skills, such as computer programming, when developing technology. Human-centered design, or HCD, is a design strategy that computer science students can use to develop these so-called soft skills by identifying a problem and then developing a novel technological solution to it. HCD is an approach to design that involves placing people, their concerns, and their activities at the center of the design process. Central ideas of HCD include developing empathy for users, understanding their context, and iterating continuously on design ideas. The approach generally has three phases: understanding users by conducting qualitative research, ideation, brainstorming, and sketching design ideas that are guided by findings from this user research, and then eventually building a prototype of one of your design concepts, and then implementing it or evaluating it with your end users. Today, HCD is not widely taught in Kenyan universities. So my program's objective is to provide Kenya's future innovators with the skills needed to contribute to the entrepreneurial innovation that is crucial to their country's economic growth. To achieve this goal, I have developed and implemented a human-centered design mini course modeled after one that I've taught at Michigan State for nearly 10 years. To date, I have taught 2 iterations of this week-long course at 2 Kenyan universities. The first is at Jomo Kenyatta University of Agricultural and Technology, and the second one is at Edgerton University. And to date, nearly 100 students have participated in this course. During the course, students work together in groups of 5 and 6. They begin by choosing a problem to solve, and then use a human-centered design approach to solve it. Questions guiding these problems include how to improve students' access to mental health care, how to improve plastic recycling on campus, how to track students lost or stolen laptop computers, and how to deter birds from eating farmers' rice seeds. Students then learn about the various design methods used in human-centered design via lectures, and then collaboratively engage in the human-centered design process. They begin by conducting user research, mostly using interviews and observation methods, analyzing their data to refine the design problem they want to solve, and then ideation, using the problem to brainstorm multiple solutions, and then using sketching techniques taught in class to visualize these ideas and to discuss them with others. Finally, they implement or evaluate their design concepts by making a low-fidelity prototype, you see one in the image here, using found materials to communicate their ideas and to ultimately evaluate them with users to get some insights into whether or not their concept might be useful in addressing the problem that guided its development. The class concludes with teams making a final presentation, as well as discussions about how to pursue support so that they can move forward in developing their ideas. I also administer a short survey at the end of each course. So in addition to an exciting collection of novel prototype design concepts that are guided by the issues that are important to students and that account for their local context, other outcomes of this course include a deep respect for soft skills, talking to people, drawing and sketching, as well as making prototypes out of found materials. Another outcome is a deep appreciation for interdisciplinary approaches to problem solving. Computer science students are primarily involved in these classes, but students from agriculture and disciplines like soil science and economics also participate. And an appreciation for working together with people with different skills is also an outcome of this course. Finally, in terms of feedback for me, students have encouraged me to continue practicing my Swahili, but for the most part, the feedback for the course has been highly positive. So I want to thank the funders for this project. It's been funded by the National Science Foundation as well as Google, and I'm in the process of looking for more support so I can continue these efforts at Kenyan universities.